Drew's Technological Review, take 27. Hello and welcome to the first edition of Drew's Technological Review, brought to you by Loosener's Castor Oil Flakes. Today we're going to take a look at a supervisory control and data acquisition human-machine interface. In other words, we're going to control this kiln with a computer. This kiln in front of us is old school, 4 mechanical switches controlling 4 elements. The heat is monitored with a pyrometer on the left there. So what we've done is hacked into the power line here, turning off the power first. And we installed a digital controller and a power relay known as a solid state relay. So let's take a closer look at the system, and hopefully I can help you to understand its operation and how it isn't very difficult to put one of these together. Alright, now I know this can seem like a whole bunch of electrical gobbledygook, but it really isn't all that. On the right is the digital controller. It's mounted in a plastic electrical box from the hardware store. Now on the back of the digital controller are a whole bunch of screws where you attach wires depending on what you want to do. Now coming out of the left side of the box are 3 connections. The top connection is the power supply for the controller, regular household current. The bottom black connection goes to the solid state relay, telling it to either switch on or off. And the yellow connection is a thermocouple wire, which goes to the thermocouple in the kiln to gauge the temperature. So the thermocouple reports to the controller the temperature, and the controller either switches on or off the solid state relay. On the right is the USB cable, which allows your computer to manage the digital controller. It's really that simple. Now also in this box, besides a bunch of wires, is a USB module. This connects to the back of the controller with a couple wires, and then you can plug in your USB cable. Now you'll need software drivers for this, so I recommend you buy a USB module where the computer circuitry is made by a company called FTDI. That's F as in Frankfurter, T as in T off times the 10, D as in doo-doo, and I is intolerable. They're a reputable company, be around a long time. Now the type of module you'll need is called a RS485 to USB module. Now the key to this operation for the average Joe and Josephine on a budget is the ability to interface the controller and the computer. Now you need software for this. There are open source software options that allow you to make a program that can do this, but that's rather steep learning curve for most of us. The maker of this controller, Solo, S-O-L-O, offers free software to interface with their computer. And frankly, that's huge, and I don't know of any other controller companies that do this. Paid options are rather expensive. You should be able to get a quality USB module online for $10 to $12. Now let's take a quick look at the connections coming out of the side of the box. Now we see at the top the power connection for the digital controller, which doesn't come with an on-off switch. The power interface I pulled off the back of an old computer which didn't work any longer. The other black connection is rubber wrap around the wires which go to the solid state relay, and the yellow wire cable goes to the thermocouple. Now how you manage these wires is a matter of choice. Please be sure everything is solid and secure, and at the end of all your wires you use connectors, crimp them well, solder them, and finish them with heat shrink for added stability. For the electrical connections within the box and its power supply and the wires going to the solid state relay, you can use 16 to 18 gauge copper wire. The gauge wire for your kiln's power supply, of course, depends on your particular kiln. Now taking a look at the Solo controller, model 4896 VRE, a good choice if you're a glass worker and you want ramp and soak temperature control. Now these controllers come in 4 different sizes between $90 and $120. These controllers and the associated software can be found at automationdirect.com. who I do not work for. And on the side here we have our Universal Serial Bus version 2, aka USB. Now taking a look at the relay, this is called a 3-phase solid-state relay. It's basically an on-off switch, turned on or off by the 2 wires attached to the bottom coming from the controller. It's a 220 circuit, so there are 2 hot wires coming in, 2 hot wires going out, and the ground attaches to the heatsink, which we'll take a look at in a minute. Now this relay is capable of handling a 60 amp load. The Kiln is a 28 amp load. It's good to have twice the capacity with your solid state relay than what you will need. When you operate these relays, heat is generated within. That's why they're on a heat sink. And they can get quite hot if you really push their capacity. So it is a good approach. I purchased this relay off of eBay from China for $34 delivered. If you tried to buy it in the U.S. From a U.S. manufacturer, you'd pay 5 times that amount before postage. This relay was recommended to me by some real helpful folks at doityourself.com, their forums. I'd highly recommend you check them out if you need any technical assistance. And a quick look at the aluminum heatsink. There's a standard size for 3-phase relays, and one uses a thermal compound between the heatsink and the solid-state relay to help with heat dissipation. Alright, let's take a look at the computer interface. Now this won't be an exhaustive review of the program because I don't know it, and also I think it might impinge upon the intriguing fast-paced action of the video. Before connecting to your computer, you'll have to manually input some settings into the controller, your communication settings, including the ability of the controller to be online and connect with your computer. In Windows, you find the settings for your USB communications port under the Device Manager. Make sure the settings within the controller and within Windows are the same. Then with the proper communication settings, we can open up the configuration dialog for the controller. So we can see a graphic of the controller which shows the temperature of the inside of the kiln to be 235 degrees. It's called the process value. And the temperature we want to reach is 400 degrees. That's called the set point value. Now this controller is capable of a variety of heating and cooling modes, and with the settings it offers quite fine control. Today we'll just be doing a simple on-off similar to your kitchen oven. And then we go over to the operation mode and set it to run. Take a look at the controller. Green light has come on. We're operational. And so let's skip ahead so we don't have to watch it count up to 400 degrees. Alright, we're back. Let's bring in the Kiln cam, which isn't part of the software. And we can watch as it hits 400 degrees and the elements will kick off. The temperature continues to rise as it does in your home oven. Settings within the controller will allow you to ease the temperature up to your set point. Well, that's my story and I'm sticking to it. I hope you found this video helpful, informative, and intriguing. Please feel free to contact me with any questions, comments, criticisms, critiques, or miscues. Good night, Junebug, wherever you are.